Hello, coffee roasters. Neil Wilson here, and there's just been a new release of CRUCS that I'm pretty excited to share. The big feature is there's this whole new analysis section, and that's what this video is about. Let's start by bringing in some data by going to the import section. For this, I'm going to pull in a file exported from Typica. First, I want to check the import options and make sure sampling strategy is set to none. That means that CRUCS won't try to smooth out the data to make it easier to edit. It'll just make every single measurement its own control point. Then I'll just drag the first file from my file manager onto the import control. You could also hit the Browse button and open the file in the dialog the browser brings up. Since this data is straight off my production roaster, I do have a little more information than I need. So going to the layers section, you can see that I have two layers now, one for each temperature probe on my machine. The analysis section is really only intended to work with the temperature of the coffee. So this series with my inlet air temperature will just confuse that. I could keep that in my main view and just turn it off in the analysis section by unchecking the analysis box, but I'm going to go ahead and delete the layer entirely. Then on my bean probe series, I'm going to uncheck show rate since that won't be relevant. And then for the sake of clarity, I'm going to make two more changes. I'll change the color of the data series, and I'm going to change the layer name to slow. Now let's hide those controls and see what we've got. This batch was a decaf Ethiopian coffee, not the one I have in the shop at the time of this recording. And if we look at the start of this, we can see that this starts out pretty slow. Low and slow is one of those classic pieces of advice for roasting decaf coffees, and it's one that I think is outdated for a number of reasons, especially if you're trying to do a high-quality decaf coffee, but it worked for what I wanted to get out of this one. I would say that even if you did want to do a low and slow, this is probably lower and slower than you really want for most coffees. Then toward the end, I pushed this a little faster because this is a coffee that just opens up really nicely right at the start of second crack, and I didn't want to keep the slower pace between cracks as that would have made the coffee less vibrant, a little flatter than it could be. So, as always, there were sensory reasons why I went with this particular roast profile for this particular coffee. My current decaf Ethiopian is quite different, roasted both lighter and faster, but that's not the coffee I'm talking about today. Now I'm going to go back to the import section and bring in another file representing a different roast of the same coffee. Once again, I'll go to the layers section to remove the air temperature, hide the rate, and I'm going to change the layer name on this one to fast. Now we can see that these look very different. The fast roast starts a little hotter, stays hotter throughout the roast, and while these are ending at about the same temperature, there's a pretty big difference in total roasting time. There is some other relevant data for these batches. These were run through my benchtop Javalytics degree of roast analyzer, which I have set to the Agtron Gourmet scale, and both batches came out at about 34 whole and about 50 ground, within a point on both of those, so same color. These also both passed taste tests, so while it would be impossible to do a meaningful side-by-side comparison between these batches, they matched the same flavor spec. The percent weight loss, however, is very different between these two batches. The slow roast came in at about 15.5% loss, while the fast batch was only about 12.5%. With all of that information, some of you can probably guess what's going on now. While green coffee is a lot more stable than roasted coffee, it can change over time, and decaf coffees in particular tend to be a little less stable. Sometimes that's going to impart tasteable differences, but in this case what happened is that in the time between these batches, the coffee dried out a little bit. Enough to change how the coffee responds to heat in the roaster, but not enough to change the flavor, provided that the roasting is adjusted to compensate for the difference. If you think back to that first batch, it was described as a low and slow. The coffee had more moisture for this first batch, and water has a high heat capacity. That means it takes more heat to get an increase in temperature compared with the batch that starts with a drier coffee. Because of how low the heat was set on the first batch, there's not a good way to match the start of the roast in the later, drier batch. The fuel setting doesn't go low enough without cutting out. Interestingly, there's less difference in moisture between the two batches the farther into the batch you go, so the closer you get to the end of the batch, the more similarly the coffee responds to control changes at the roaster. So the start of the batch isn't going to match, but this is also the least significant part of the roast when it comes to known chemistry that connects to tasteable differences in the finished product. The working theory here is that when you have this kind of early difference in the roast, the best thing you can do is pretend you did hit your milestone and try to match up the rest of the roast, but with the time offset. So if you hit your first milestone early, you want the next one to also be early by the same amount and continue to stay early through to the end of the roast. If you let your batch data get closer to the plan, that's compensating for a difference in a range where the difference doesn't matter, with changes in a range where that change is more likely to produce a tasteable difference, which is not what we want to do. Let's switch to the analysis section and see how I did at that. The default range is just the whole roast from start to end, and we can see some statistical information. The farthest apart these batches get are a little over 40 degrees, 5 minutes 15 seconds into the roasts, and the average difference is a bit under 30 degrees. But that's not very useful, so I'll change the range definition to something more interesting. On a regular coffee, I'd have my color change from green to yellow consistently at 300 degrees, and that's conveniently also where we start to get chemistry that's responsible for tasteable changes. I'll also change the range name to something more descriptive. Now the two data series show up almost right on top of each other, and we can look at this data table to see what's going on here. The difference in duration for this part of the roast is only 0.3 seconds, which is effectively the same. The largest difference is 1.4 degrees, but the average difference is only 0.7, so despite the huge early difference, where there's a difference of 1 minute 39 seconds before we get to the significant part of the roast, once we get to that part of the roast that matters, this looks like a very good match, which explains how both batches matched the flavor spec. Well, there isn't much point to further breaking this down with batches that are matching up this closely. It can be useful to further dissect this if we had batches that were more different or where there was a tasteable difference between the batches. This is also useful when trying to do roasting exercises where maybe you want to change a range in the middle of the roast, but want to keep everything before and after that intended difference the same. You can use multiple ranges to confirm that you have close matches in the parts of the roast you're trying to keep the same, and differences only in the parts of the roast where you wanted those differences. I'll just go ahead and create a few more ranges that I personally find useful to have to show how that works. Clicking New Range sets up a new range. I'll start with yellow. The same starting temperature of 300 degrees. And I'll set an end temperature of 330 degrees. Another new range. Let's call it brown. And we'll take the 330 as our start this time and go out to start of first crack, which on my machine happens consistently at 380 degrees. Then we'll go with a range for between first and second crack. So our 380 is our start temperature. 430 is the end of the range. And we'll do one more, which won't be very interesting for these particular batches, but I think it's useful to treat everything after second crack as its own separate range. So on my machine, second crack starts at 430 degrees, and we'll let that run to whatever the end of the roast is. Now if we scroll down, we can see those other ranges. Recall that the blue line is the slower roast, and the red line is the faster roast, and we can see that the fast roast is getting into yellow a little slower, but pulling ahead by the end of the range. It's important to keep in mind that we're really zoomed in on a small piece of the roast. The difference in duration within that range is only 3 seconds, and we're always under 1 degree difference. Brown is a little closer, only 2 seconds difference in the opposite direction, and you can see that the lines are almost perfectly on top of each other for most of the range. Between cracks, we see a little more of a difference, on average 1 degree difference, only 1 second difference in duration, but the faster roast stays a bit below the slower roast. You can see that the max difference here is a little higher than the max difference for the full significant range from yellowing to the end. That's not uncommon to see because we're dealing with different offsets in these two views. And then since we're stopping right at the start of second crack, there isn't anything useful to see there for these batches. All of those range definitions get saved, so you only need to set up the ranges you're interested in looking at once, and those will be ready the next time you want to use this feature without needing to do that setup. This kind of profile translation analysis is a powerful tool for more accurately connecting differences in observed flavors with differences in how those batches were roasted, or for setting appropriate tolerances for how far off you can get in different parts of the roast while likely getting close enough results in the cup. This should never be used to replace tasting the coffee, but it's incredibly useful for contextualizing what you're tasting and connecting those observations with your roasting data. As always, if you find this useful and want to support keeping CRUCS available and future improvements to that, you can head over to crux.net and click on support. Financial contributions are always appreciated, and thanks for watching.